We're going to apply substitution method to find different integrals. Let's go over one example. We're going to discuss the type when you have the square root of, for example, a quantity inside parentheses in terms of x. Here the question says, find the integral of 2x square root of x squared plus 1 dx. So when you have integral with quantity inside the radical, let us use u sub px. Then the derivative of u is p prime of x dx. So this is the general approach. In this case, ux is equal to x squared plus 1. We're using u sub x squared plus 1, so du is 2x dx. So we're going to convert this integral into an integral in u and du. So we can convert the original integral in x into an integral in variable u. So let's take a look. The integral symbol stays the same. What do I have? I have 2x dx. 2x dx. Another name for 2x dx is du, and you have square root of x squared plus 1. Very good. So let me use a different color. You get the integral of u du. From integral in x, we converted that into an integral in u. Why? Because it's easier to find this integral. We already know that the integral of square root of any quantity like x, t, u can be written as the integral of u to a half du, which is u to a half plus 1 divided by a half plus 1 plus constant of integration, right? So this integral becomes u to 3 halves divided by 3 halves plus c. But we're not going to stop here. The original integral is in x, so the outcome must be in x. But what was u? u was x squared plus 1. This becomes x squared plus 1, 3 halves divided by 3 over 2 plus c. Let's do a little bit of algebra. 2 times x squared plus 1 times square root of x squared plus 1 divided by 3 plus constant of integration. Again, if you go back to algebra, if you have, for example, a quantity to power 3 halves, this is actually the square root of px to the third, which can be written as px times square root of px.